So following up from the previous video, we concluded in that one that we have the equivalence of 360 equals to 2 pi. And we can actually come up with different equivalences by dividing or multiplying either side by any number, and that way we can find different equivalences. You can even try on your own, divide this by 2 pi to get 1 radian, and see how much 1 radian is equal to as a degree. So just do that. So this would work when you have kind of nice multiplications on one side or both sides. So, but I want to do the formal way of converting between radians and degrees. You can memorize the formulas if you want to, but I feel like memorization might accidentally fail you in an exam or so. The general thing is that if you have, if you want to convert from radians to degrees, you multiply by 360 over 2 pi. So this is from radian to degree. You multiply by 360 over 2 pi. And then if you want to have degree to radian, you go 2 pi over 360. Now you can memorize this if you want to, but what I like to use is the equivalence and cross multiply method. So how does that work? Also, I do not use 360 and 2 pi. Most commonly, mathematicians use 180 and pi because it's just less numbers to deal with. You don't have the 2 here, so at least dealing with just 1 pi is easier. So we have, let's say for one example, let's say I want to convert 120 degrees to radians. So the way you do it is just put the equivalence here. It's actually the same as converting anything, even currencies and stuff. So this is 120, and then you have the x. So now that I have the equivalences, I can cross multiply. So that gives me 180x equals to 120 times pi, and then you solve for x, so you have 120 times pi divided by 180, and you should, there are some conversions where you should be able to do without a calculator, because they do show up in non-calculator papers. So this goes, and then I can divide both by 6, so I get 2 and 3, and so I have 2 pi over 3. And leave it as a fraction, especially if it's a fraction in the simplest form. So radians are expressed as fractions in terms of pi. So if you can get to this form, that's great. But if you end up with something like 2.4 pi over 3, this is not a proper fraction, because proper fractions should have integer values in the numerator and denominator. And when I mean proper, I don't mean the mathematical proper. It could be top heavy, but 2.4 is not an integer, so this is not a correct form for a fraction. So in this way you can convert it to a decimal, but most of the time if it's a fraction in its simplest form, just leave it as that. And then we could continue with another example, and the other way around. Let's take let's convert pi over 6 radian to degree. And you do the same thing. We have 180 is pi, and we have x equals to pi over 6. We have an equivalence. We cross multiply, and I get x equals to, I'm just going to jump with it's 180 times pi over 6, and then the whole thing divided by pi. So because everything is being multiplied, so I can actually put this under one fraction, so the whole thing is divided by pi. So just to write this in a nice way, 6 pi, everything's multiplication, so I'm allowed to do all of this, bring everything into one denominator and so on. So then I could cancel things out. So this cancels out. The 6 and the 180 cancel out. This will be 30. So I have 30 degrees. And this is one of the common degrees you should be familiar with, pi over 6. So 30 degrees is the answer, and it should be easy to do. So hopefully this video is clear in terms of conversion. You can memorize the method, so as you can see, it's always a, as I mentioned in the beginning, I said it's 360 divided by, it's 360 divided by, that you get the 360 divided by 2 pi, that would convert to radians to degrees, which is this 180 divided by pi. And then for above, I said it's 2 pi divided by 360, which is kind of what we had here. We had the pi over 180. So you can memorize it as such, but you can use the equivalences, it's quicker.